Imagine asking an AI application to find a meeting time, read a project file, and email the team. The application understands the task, but it must connect to several different systems. Without a common standard, each connection may need its own custom setup. As more systems are added, these connections can quickly become complicated. Without a common connection standard, every AI application may need its own custom integrations. AI application A must connect separately to the calendar, database, and files. AI application B must then build its own connections to those same systems. As more applications and systems are added, many integrations must be built and maintained separately.
MCP stands for Model Context Protocol. It is an open standard that gives AI applications a consistent way to connect with external systems. Through an MCP server, the application can discover tools, resources, and prompts that it may use. Instead of building every connection in a completely different way, MCP provides one common method of communication.
Different AI applications may need to connect to different MCP servers. The AI assistant connects to the calendar MCP server, the coding app connects to the files MCP server, and the workflow app connects to the database MCP server. Although the applications and servers are different, every connection uses the same MCP communication standard. This gives them one common connection language, instead of requiring a completely different custom integration each time.
The MCP architecture has three main parts: the host, the client, and the server. The host is the AI application the user interacts with. Inside the host, the AI agent or model works with an MCP client. The client communicates with one MCP server using the MCP standard. The server may then provide tools, resources, and prompts, while information can travel in both directions between the client and server. When the MCP client connects to a server, it first learns which types of capabilities the server supports. The server may provide tools, resources, prompts, or a combination of them. The client can then request a list of the available items in each supported category. The server returns details such as available tools, readable resources, and reusable prompts. This discovery step tells the client what is available, but nothing is automatically used or executed yet.
MCP servers can expose tools that allow an AI agent to request specific operations. In this example, the agent needs to find an available time after 3 o'clock. The Calendar MCP client sends a tool call to the Calendar MCP server, which runs the check availability tool. The server may use the Calendar API to communicate with the Calendar service behind the scenes. The Calendar service finds that 3:30 is available. The result then returns through the Calendar API, MCP server, and MCP client to the AI agent. Discovering a tool and invoking it are separate steps. MCP servers can expose resources that provide information and context. In this example, the user asks about the company's refund period. The Company Knowledge MCP client requests the refund policy from the MCP server. The server returns the policy content, which states that refunds are allowed within 30 days. That information travels through the MCP client to the AI agent, which answers the user. Unlike a tool, a resource provides information. It does not perform an action or change the original document. MCP servers can expose reusable prompt templates. In this example, the user selects a prompt called "Prepare a refund response." The customer support MCP client retrieves the selected prompt from the MCP server. The server returns a template instructing the AI agent to read the complaint, check the refund policy, and draft a helpful response. The agent then uses those instructions to prepare a draft for review. Prompts guide the AI, but selecting a prompt does not perform an external action. One MCP host can connect to several specialized MCP servers. Inside the host, each server has its own dedicated MCP client.
The calendar client checks the schedule and returns a meeting time of 3:30. The files client retrieves the project brief, while the meeting prep client retrieves a user-selected prompt template. Each result returns through its matching client to the AI agent. The host then combines everything into one meeting preparation result. This allows one AI application to coordinate multiple MCP servers without mixing their separate connections. MCP connects the AI application to external capabilities, but the AI application still decides what to do. In this example, the AI agent understands the meeting preparation task and selects the project brief resource. The meeting assistant MCP client sends the request to the MCP server. MCP standardizes the communication, carries the request, and returns the result. The server provides the project brief, and the result travels back through the MCP client to the AI agent. MCP does not think, plan, choose the user's goal, or automatically grant unlimited access. MCP is the connection standard, not the intelligence.
To summarize, MCP gives AI applications a standard way to connect with tools, resources, and prompts. The AI decides what to do, while MCP standardizes the communication. Next, we'll build a simple AI agent, step by step.